Okay, so back in the code of VEC, and we're thinking about testing and test-driven development. So what I'm going to do is I'm going to open up a split pane here. So Control W for a window command, and then V for a vertical split, and then Control W again, and then L to move my cursor over to the left side of the right side of my screen. And then I'm going to pop open my file explorer with Control O and go to my test directory, unit test, and vec.c++, and then close my file explorer again with Control O. So you'll see here that we have set up some simple unit tests to get us started. And we've gone ahead and implemented some tests for, say, the value function. So vec value test is here, and that corresponds to this value constructor. And you can see we're just testing that some of those properties are set up as we would expect based on the parameters we passed in. And one of the things I want to point out is when you're doing unit testing, it's not uncommon, and in fact, it's almost always required that when you're testing an initial implementation of something, that you're going to need to dig into the abstraction and understand its members more than you would if you were thinking about this from a pure barriers of abstraction standpoint. So what I mean by that is, when we set up this vec value, if we want to test that that actually did what we thought it would, notice I'm having to access the length member of my vec here directly, right? And same with capacity. And we want to see that capacity was initialized to be 10 as we expected. And then same with buffer. We want to see that it's actually initialized as we expected there as well and wasn't null. And so this like digging into the members of a struct is something that you'll find yourself doing in a unit test to convince yourself that that function is doing what you expect it to do, right? And it's following those assumptions. Same with drop. With drop, we are just checking that those properties are updated as we expect. And then I went ahead and added a few of the most basic possible unit tests for ref and set and get, which are our focus for this next unit. All right, so let's narrow in on ref really quickly. So I'm going to use Control W and H to go back to my left-hand side, and I'm going to go to my ref function here. So this is, again, a function whose purpose is to return a reference to or a pointer to a specific item in our vec at some given index. And so what's the simplest test we could imagine if we're following some test-driven development here for knowing whether or not this works? Well, what we can do is we can set up a brand new value, and here we're going to make use of our constructor vec value. We've got a test. That test already passes. We're convinced that this is okay for us to rely upon. And now what we're trying to do is test whether or not the element at index 0 is, or the ref of the value at index 0 is going to be the same as this buffer, right? And so this buffer's address is going to, because it's just an array that's on our heap, it's going to be a pointer to the very first byte of the very first item in our buffer array. And so we expect that the index 0 item in it will be the same. And that's what we're making this assertion about here. But we can see in our implementation, this is just a skeleton implementation. Remember, we want our failing test to be ready for us to go first. And so here we've got a failing test. It's just going to return null. So if I use the exclamation colon exclamation point, let me make sure that can be seen on the screen. So colon exclamation point and make unit test here. We'll see some compilation happen. The first time you do this, it's going to be a little bit longer than mine. I've already compiled this once. And what we can see in our output here is the test for vec ref, and we see that it failed, right? So this vec rest test was run, and we expected v.buffer to equal vec ref at index 0. But notice this was the result that our function actually returned null. And what we expected here was an address of our first element, right? So how do we fix this? Well, what I want you to try doing is pause the video and see if you can get this test to pass. Right? And there's a simple way of doing this without any arithmetic whatsoever for this particular test. And then there are more complex ways. And I would encourage you to just try getting the simple case of this test to pass first, and then we'll continue on. All right, so a simple test, or a simple way of passing this test here is we just return the buffer, right? And we still have this warning of an unused parameter, but that's okay. Let's see if we now pass this test. All right, and now we see, oh, sure enough, we passed that test. But this isn't all there is to the story, right? This test passes because this is what we're expecting for an index 0. But we should probably try, now that we've got a very simple test passing, to add a test that's a little bit more robust. So here, let's copy this. So I'm going to use Shift-V to go into line visual mode, and then Y for a copy, and then I'm going to paste it down below. And you're going to see we have an error, which is we've got a redefinition of a test with the same name. So our names of our tests here, these two parameters have to be different in some way. So we're going to keep vec as the unit we're testing, and then the ref name of this test will be ref underscore and maybe just 1, right? And so now what we can see is we need to modify our test to be a little bit more resilient to this problem that we saw. We're trying to see if the element at index 1 is equal to the buffer plus 1, however big, however many bytes are in an int 16, right? So let's break this down a little bit. We need a little bit more specificity in our test here, right? So first of all, we're going to have to go behind the scenes and add an element or two to our vector manually, and do this without using the other functions because we haven't implemented get and set yet. So what we can say is we can set up an alias for our int16t buffer. This will be a pointer. That is v.buffer, right? And we can assign to index 0, say a value of, I don't know, 211, and buffer index 1 a value of, say, 311, right? And we're also going to want to manually specify ourselves that the length, the number of items we now have stored in this particular buffer are 2, right? This would have, normally when we set these values, we would have made those, the length would have been updated itself, but we're kind of working around in this abstraction ourselves and getting these values initialized. The other thing we need to do is cast this, because v.buffer is a void pointer buffer, and we need to cast this to an int16 type pointer. All right, and so we know that vec value initializes this to actually be, like, the size of this buffer would be 20 bytes, right? Because an int16 is 2 bytes, and there are 10 elements that we were initially computing the capacity for. So v.buffer would be 20 bytes. And we've stored 2 values in it, and we've updated the length ourselves. So now what we're trying to say here is we want to ensure that when we ask hey vec for the ref of index 1, we expect that to be the same as index of buffer 1, right? And if we wanted to just convince ourselves that this was working, we could also do it like this, right? And so here, we know behind the scenes what we expect is happening behind this abstraction to convince ourselves that this is working, right? We've got this buffer that, even though the vec class doesn't know, or sorry, the vec struct doesn't know exactly what type it is, and so it's having to treat this buffer as a void pointer, we know, because of how we initialize it and how we're using it, it's actually going to store int16 data. And because of that, we can confirm that the address of buffer index 0 should be the same as the return value of asking this vec for its index 0. Now this is going to fail, right? So let's try running this, make unit test. And once we get this built and tested, we'll see that this isn't going to work because our implementation was naive, right? So here, notice that we expected, this must have passed for the very first index, right? For index 0, but for index 1, we're expecting the actual address is A2, the hexadecimal address with ending in A2, But the value that we got back was A0 because all we did was return the very first address of this buffer. So we need to do a little bit of pointer arithmetic to be sure that this is relative to the index that we're trying to get the address of the element for, right? And so we can see that these are off by 2 because we're storing int16 data. Okay, so let's try this out. So we're going to improve our logic here and say self buffer plus index multiplied by, and then how big is each item in our array or our vec? Well, that's stored in a property, self item size, right? And so item size, when we construct our vec, is going to be the size of each item, in this case 2 bytes. We multiply that by the index we're trying to find, and we add that to the address of our buffer, the starting address of our buffer. So now we try make unit test again. And this time around, not only our first ref test works, but that second test works. And that feels pretty good, right? So we started from a point of a failing test that was as simple as we could imagine. We did as little as possible to get it running, but we kind of realized in our heart, we know that that wasn't a good enough implementation. So we went and we added another edge case, or actually a use case we could think of. We had to do a little bit of dirty work here to get it working as a test because we didn't have other methods working. We'll talk about that in just a second. But we got it working, and this was sort of the feel of a test-driven development that you could follow for Git and set, which we'll be looking at next.